So there's one new type of terrain feature that we're going to explore in this section where we're discussing maximums and minimums, and that's something that's called a saddle point. So we're defining what we mean by a saddle point here, and here's a visualization of a saddle point. And notice that if we restrict ourselves to just the x direction, that this point behaves like a local min in the x direction. So in one direction it behaves like a local minimum. In another direction it behaves like a local maximum. So the direction doesn't matter, and in fact it doesn't have to be in strictly the x or y direction, but in a direction it behaves like a local maximum, and in a direction it behaves like a local minimum. That's what we mean by a saddle point. In order to be a saddle point, then, we're going to have to say that that ordered pair is something called a critical point, which we haven't defined yet. We'll define that on the next page. And for every open disk that you put around it, you have points where you have points that give an output greater than that point and points that give an output that is less than that point. So the word there we want is and. It's important that it behaves that way. So folks, we now are interested in defining what we mean by a critical point. And we had a similar definition in Calc 1, but this is a little bit more elaborate. So if we have an interior point in the domain, this is important, folks, because our theory is going to be broken up into studying the boundary points of a function versus the interior points in the domain of that function. And so we're restricting ourselves right now to just the interior points in the domain. Then we're going to say that f is a critical point, or excuse me, an ordered pair is a critical point of the function f if either one of the two things happen. Either both partial derivatives exist and they equal 0, or at least one of the partial derivatives does not exist at that point. An equivalent way of stating this is that the definition of a critical point is either is a point interior to the domain, either where the gradient is the zero vector, or where the gradient is undefined. So that's an alternate way of giving the definition of a critical point. Okay, so basically, like we were doing in Calc 1, we are looking for, when we go looking for our potential local maximums, local minimums, and saddle points, we're going to be looking at where our partial derivatives are 0. That's essentially what we're doing.